So for this question, we are supposed in part 1, we need to write down the line of symmetry for the graph. So line of symmetry is basically the line that cuts the the curve into two equal parts. Right? So the line of symmetry is also the vertical line that passes through the turning point of the graph. So you can see that this is the line of symmetry quite easily, and the equation is just x equals to 7, right? So note that when we are talking about vertical line, it's always x equals to something, right? So it's just x equals to 7. Now for part 2, given that the negative x squared plus 14x minus 24, which is our curve here, has two distinct solutions, right? We need to state the range of values for k, right? So what it refers to is that if you imagine that there is another curve here, which is 1, right? And there's another curve here, which is y equals to k. These two distinct solutions simply also talks about like the number of intersections, right? So if there are solutions, also can relate to the intersections between the two graphs. So if we consider the horizontal line y equals to k, where k is some unknown value as equation 1, and the second equation, which is y equals to negative x squared plus 14x minus 24, whereas equation 2. Now considering that if we were to solve simultaneously, so example, if we were to find the solutions, right? This is the same as finding the intersections between equation 1 and equation 2. Right? Because if we were to solve them simultaneously, what you do is you probably sub 1 into 2 and you equate negative x squared plus 14x minus 24. So imagine that this is one curve and this is one line, and basically the solutions to these equations, right, can be found by finding the intersections on the graph. So if you consider drawing a line, say y equals to k, say for example, say y equals to 5, okay, you can see that these two intersections, or these two solutions, right, intersections, will satisfy y equals to 5 as well as y equals to negative x squared plus 14x minus 25. So in this case, if k is equals to 5, the intersection between the two functions, right, okay, the two equations will also give you the solutions to this equation, right? So solutions here basically we are taking the intersection of two curves. One is y equals to k, and one is negative x squared plus 14x minus 24. Now taking these two, right, the intersections give us the solution. Now if it continues to have a lot of two distinct solutions, you can see it y equals 2 solutions. If I keep going up, 2 solutions, 2 solutions, 2 solutions, my k can be, really this is k, y equals to k, y equals to k. There'll come a point where no longer will I be able to hit two intersections, which is at the point here, the turning point, I believe is 7,25, right? By reading of the graph, 7,25. So if your y, right, for example, is y equals to 26, it can no longer cut the curve. And y equals to 25 can only cut the curve at one point. This means that there will only be one solution, right? So what does it mean is that this k, or this value here, has to be less than 25 in order for me to continue to cut at two solutions, right? Because anything more than 25, if I take a horizontal line, so for this y equals to k, remember what we are doing is we consider the line y equals to k to intersect the curve. If k is less than 25, then yes, we can intersect it 2 times. Otherwise, we can only intersect once, or perhaps even 0. By drawing a suitable line on the diagram above, in part 3, we need to solve the equation negative x squared plus 13x minus 14. Now, what we know is for this question, right, equals to 0, what we are given so far is we are given next negative x squared plus 14x minus 24. This is our graph that we are given. So what I want to do is I want to make this appear again, and I'll show you that if I can make this appear again, then whatever you see on the right hand side, if I were to just draw that graph, right, that will also give me the intersection. So this, by adding x on both sides, you can see that I can get negative x squared plus 14x minus 14 equals to x. Next, I subtract another 10 on both sides. That gives me negative x squared plus 14x minus 24 equals to x minus 10. Okay, so what do I do here is you can see that the solution for the first line should be the same as the solution for the second line, because these are all equivalent steps, and it should be the same as the solutions for the third line. What's so beautiful about manipulating the first line to the third line is the third line, we can make use of the graph that we have already drawn, and simply I just need to draw x minus 10, y equals to x minus 10. So if I draw y equals to x minus 10, if I just add this line onto my graph, then the intersection between these two curves, right, will give me the solutions to this equation. Right, so if I draw y equals to x minus 10, and if I draw y equals to negative x squared plus 14x minus 24, the graphical solution between these two, right, will give me also the solution for the second step, and hence the solution for the first step. That is how I solve my original equation, and you can see the strategy is to manipulate from the end point, from the start point all the way to the end point, right? Negative x squared plus 14x minus 24. So this is what I will draw. I will draw y equals to x minus 10. Let me just tidy up my curve a bit. So y equals x minus 10 is not difficult. This is minus 10 is here. When y is 0, x will be equals to 10. Right, so let me just draw my line here. Okay, it must pass through at least 2 points, these 2 points over on this part. Okay, and from here, oh sorry, I didn't draw it so well, but I mean, if you pardon me because I'm using an iPad, with your pencil it should be better. Okay, you can see that this is the equation I'll draw, which is y equals to x minus 10. So the intersection between y equals to x minus 10 and negative x squared plus 14x minus 24, the intersection between these two will also solve the solutions that I have, the equation that I have. So by reading off the answer, I think you can see x should be about approximately 1.2 or probably 11.8. Okay, thank you.